Skilled workers like this produce about 1,200 a day.
Each machine makes 1,200 cigarettes a minute, or 20, a package full, every second.
Once hand-rolled one at a time by skilled workers, producing only a few cigarettes per minute at their fastest, the cigarette by the 1910s had become a product manufactured by machines at speeds that made individual craftsmanship economically irrelevant almost overnight. The industry that emerged from that transition was, by any measure, one of the most efficiently organized consumer goods operations of the early 20th century. Understanding how it worked requires following a leaf from the field to the finished pack, a journey considerably longer and more technically demanding than the product at the end of it ever suggested. This video will take you inside cigarette manufacturing in the 1910s to uncover exactly how tobacco was grown, processed, blended, and machine-rolled into finished products at industrial scale, why each stage of preparation directly determined the quality of what reached the consumer, and how a single mechanical invention transformed one of the world's oldest hand trades into a modern manufacturing industry. Right now, let us explore this remarkable process together. The production of every cigarette manufactured in the 1910s began not on a factory floor, but in agricultural fields stretching across Virginia, North Carolina, and Kentucky, the primary tobacco-growing states of the American South. Different growing regions produced leaves with distinctly different chemical and aromatic characteristics, and manufacturers drew on multiple sources simultaneously to achieve the flavor profiles their blended products required. Bright Virginia tobacco, grown in sandy coastal plain soils, produced a naturally sweet, mild leaf with relatively low nicotine content. Burley tobacco, cultivated in the limestone-rich soils of Kentucky and Tennessee, produced a heavier, more absorbent leaf capable of carrying added flavorings evenly throughout its structure. Imported Turkish tobacco, grown across the eastern Mediterranean, contributed aromatic complexity that American-grown varieties could not replicate. Each variety was planted, cultivated, and harvested on separate seasonal schedules, with harvest timing determined by the maturity stage of individual leaves rather than the plant as a whole. A labor-intensive process requiring workers to move through fields repeatedly, selecting leaves at peak ripeness, rather than cutting entire plants at once. Fresh tobacco leaf could not be processed or smoked in its harvested state. The high moisture content and harsh chemical profile of uncured leaf required transformation through one of several curing methods before the tobacco became usable manufacturing material. Bright Virginia tobacco was flue-cured, heated by metal flues carrying hot air through enclosed barns without exposing the leaf to smoke or combustion gases, with temperatures carefully staged from low initial heat through progressively higher finishing temperatures to fix color and chemical composition. Flue curing typically required approximately 4 to 7 days to complete. Burley tobacco was air-cured in ventilated barns over 4 to 8 weeks, producing a darker, drier leaf with lower residual sugar content than flue-cured varieties. Turkish tobacco was sun-cured on open racks over several weeks, while fire curing exposed certain specialty tobaccos directly to hardwood smoke during the drying process. Following curing, tobacco was packed into hogshead barrels, large wooden casks with a standard capacity of approximately 1,000 pounds of pressed leaf, and transferred to aging warehouses for a resting period ranging from several months to more than a year. Inside these warehouses, stacked hogsheads were monitored for conditions that supported the slow enzymatic activity and mild fermentation responsible for reducing harshness and developing aromatic complexity in the aged leaf. Warehouse workers called prize packers were responsible for pressing the leaf into hogsheads at the correct density. Too loose and the tobacco dried unevenly. Too dense and fermentation heat could not dissipate properly, risking damage to the entire barrel. Interestingly, well-aged tobacco was considered a measurable competitive advantage by major manufacturers of the period, and some operations maintained multi-year aging inventories to ensure consistent supply of properly matured material, regardless of seasonal variation in incoming crop quality. Aged tobacco arrived at manufacturing facilities by railroad car and wagon, packed in hogsheads weighing between 800 and 1,000 pounds each for domestic varieties, or in bales for imported Turkish leaf. Upon arrival, each shipment was inspected and cataloged by origin, variety, and grade, before being transferred to storage areas, organized to keep different tobacco types separated until the blending stage. Before processing could begin, tobacco leaves underwent manual sorting by trained workers, predominantly women, seated at long sorting tables. Each leaf was evaluated individually for color uniformity, surface texture, thickness, and the presence of damage from disease, insects, or handling. Premium-grade leaves were separated for use in higher quality products, while leaves with significant defects were either downgraded to lower-grade blends or removed from production entirely. One fascinating detail is that experienced sorters could evaluate several hundred pounds of tobacco per shift entirely by visual and tactile inspection, with no mechanical grading equipment capable of replicating the consistency of trained human judgment available at the time. Following sorting, the central stem running the length of each leaf was removed, either by hand stripping or, in larger facilities, by early mechanical stripping equipment, leaving only the soft lamina portions that would form the cigarette filler. From the sorting and stripping area, prepared leaf moved directly into the cutting department. Prepared tobacco leaf entered rotary cutting machines that reduced the material into narrow, uniform shreds, the form required for consistent filling and even burning in the finished cigarette. Cut width varied by product specification, but maintaining uniformity within each batch was critical, as variation in strand width produced inconsistent filling density and uneven draw resistance in the finished product. Following cutting, the shredded tobacco from different varieties was combined in the precise proportions specified by each manufacturer's blending formula. By the 1910s, the American blend, combining bright Virginia, burley, and Turkish tobacco in specific ratios, had become the dominant cigarette formulation in the United States market. R.J. Reynolds introduced Camel cigarettes in 1913 using this blending approach, and the brand's rapid commercial success accelerated adoption of the American blend format across the industry. Blending ratios were closely guarded by individual manufacturers, with complete formulas known only to senior production personnel. At this stage, the blended tobacco was conditioned with controlled amounts of water or steam to bring moisture content to the level required for machine rolling, and small quantities of approved humectants, including glycerin, sugar solutions, or licorice extract, were incorporated to stabilize moisture retention and modify burn characteristics. The mechanical rolling of cigarettes in the 1910s was dominated by equipment derived from the Bonsack machine, originally patented by James Bonsack in 1880 and progressively refined through the following decades. By the 1910s, improved Bonsack-type machines had become the standard production equipment across major American and British cigarette manufacturers, with the American Tobacco Company having secured early preferential licensing arrangements that gave it a significant production cost advantage over competitors during the preceding decades. The machine operated as a continuous process. A roll of cigarette paper fed through the mechanism, while a measured stream of conditioned tobacco was deposited onto the moving paper from a calibrated hopper system. The paper was progressively formed around the tobacco column as it advanced, the seams sealed with a thin line of adhesive, and a rotary cutting mechanism divided the continuous rod into individual cigarettes at the specified length. Finished cigarettes emerged from the cutting station and were transferred by conveyor to collection points feeding the packaging line. A single Bonsack-type machine of the 1910s produced approximately 200 cigarettes per minute, equivalent to the simultaneous output of approximately 50 skilled hand rollers. At full continuous operation across a single 8-hour shift, one machine could produce approximately 96,000 cigarettes, a volume that a pre-mechanization factory workforce of comparable size would have required several days to match by hand methods alone. Cigarettes leaving the rolling machines were inspected for fill consistency, length, seam integrity, and overall appearance before advancing to packaging. Workers removed visibly defective cigarettes from the production stream, those with damaged seams, inconsistent fill, or off-specification length, and where possible, tobacco recovered from rejected cigarettes was returned to the blending stage rather than discarded. Accepted cigarettes were counted into groups of 10 or 20 and packed into paper packages incorporating thin foil liners that reduced moisture loss during storage and retail handling. Outer wrappers carried printed brand identification, government tax stamps were required, and promotional imagery that manufacturers used to differentiate their products in an increasingly competitive market. Packed cigarettes were assembled into cartons, then into outer shipping cases, and transferred to the dispatch area for loading onto railroad cars and delivery wagons serving regional distribution networks. By the mid-1910s, the leading American cigarette manufacturers were producing hundreds of millions of units annually from facilities spread across the tobacco-growing states and beyond. The combination of mechanized rolling, standardized blending, and organized distribution had transformed cigarette manufacturing from a regional craft trade into one of the most capital-intensive and logistically sophisticated consumer goods industries in the country. Built on a leaf that still had to be planted, tended, harvested, and sorted largely by hand before any machine could begin its work. Whether the farmers producing that leaf appreciated the efficiency of what happened to it afterward is a question the production records of the period did not think to ask.